So I'm very glad that today we're going to start handling the real building blocks of the language itself, because I think we've managed to look much into variables and memory and all that. By the way, regarding the previous lesson, if you go to my blog, the last post, I've published some material about floating point numbers. This is a demo that I explained the previous time, but it wasn't part of the lecture of the PowerPoint. So I put it here, so you can all access it and see through it if you want some deeper breakdown of how floating point numbers are represented and why and what's their structure, and also how we take memory structure and we can make it into a floating point number, how the calculations are done, what every bit represents, and what we get to in the end. So if the material is here, as well as the recording of the lecture itself here. So just so that you know. Cool. So today we're going to start talking about methods, very important building blocks of any procedural language, and that's most of the modern languages. In some older languages, we didn't have this kind of structural programming. If you look at the old times BASIC, which was on my first computer sometime in the early 80s, you will see that the programming is line by line, and sometimes you can use go-to statements, God forbid. So the real power of C# and its all its neighbor languages like Java and C++ is the object-oriented structure of classes, and that's what we're going to start attacking. And today we're going to be talking about methods. Can I? No? Better? Thank you. Someone's at the door. So we're going to be talking about what methods are. We'll see how they're structured. We'll see how we declare them and how we call them and how we use them. And from this part on, I guess most of your programming will be done through methods. That's a very important block of every right programming structure and practice. So, what's a method? We've been using methods until now because C# only runs classes and methods. We cannot write a program without a method. And a method is a block of code that does something. For now, we've been using, except the ones who've been doing it for their homework, in order to solve some problems, we've been using the main method of the application, which is a method that has to be declared in it. But whenever we have some kind of task, something to solve, something to perform, we usually would make a method for it. And this method is specifically there to solve the specific thing, either to calculate something, to produce something, to print something. It breaks the program into much better structural and much better understanding of what it needs to do. As best practice, just as we've been using with variables, methods need to be named in a proper way, and we'll see that. Methods need to be self-explanatory of what they're doing and why they're there and what's their purpose. And there is a matter of good practice that says that if you're writing a method, it should fit in your screen. If it's too big, then maybe you have to break it down into smaller bits. Of course, this doesn't apply many times in the real world. We have long methods and we have big methods that sometimes we have no way. But the more we break our program into structural, functional pieces, it makes it better. And of course, methods are there also to help us do repetitive tasks, for example, parts of our program. So, as I said, we're splitting our program into smaller pieces. We have a better organization of what our program is made to do. Of course, it makes it better readable and better understandable. Not every time, of course, and we'll see probably some bad examples as we go, and we'll see some bad examples. Well, not bad examples, but when we'll start talking about recursion, for example, I guess it'll be harder to follow. But still, methods are required in order to give the right structure. And methods are basically there also to make our code reusable and to make it more structured in a way that once we'll be talking about classes, we'll see that a class is a structural unit which needs to represent something. And the method in a class is usually a part of it that is dedicated to that work. So it's not just the reusability of the code, it's also the function that it implements is much better in terms of its context in the class. We'll see that more when we'll deal with classes. And C# has a few ways to declare methods in a way that C# has a way to declare methods in a way that they could be very flexible. For example, when we'll see that the arguments of a method, we can make them optional, some of them, or we can add as many arguments as we want to a method, or we can overload methods. That means that the same method with the same name can do different things with two different types of data. So we'll get to look at that also. So they're quite powerful pieces of functionality, and we'll be seeing them. So first of all, we'll see the structure of a very basic method. The first thing we need to know is to declare our method's name. And what we see here is a static method. We'll know more about static when we talk about classes and accessibility, and forgot the word for it. Directives. But for now, let's just know that this method is static, but we'll probably see a bit later of what it really means. A method has to have the parenthesis, whether or not it accepts any arguments, any parameters. It has a return type. In C#, every method must have a return type, and this method in specific returns void. That means it actually doesn't really return anything. And we have our curly braces opening and closing the block, just like we've been using it in every other code block, and we've been putting it in ifs or in loops. So this is all known to you. Is this structure clear to everyone? I guess except maybe the static word here. So this is our block, and once we enter the method, this code of block will be executed in its order. Once it's finished, we're going back to where we call the method. So here we have an example of our class. This class is our program main structure, just like we've been using. Oh, just a moment. Oh, get on. So again, this is our class, this is our main program class, and we have our main function here. In this case, the main function is also declared as static. That's less important right now. And we have our method here that prints a logo. It prints two lines, one with Telerik and one with the Telerik site web address. And in order to call this method, all we have to do is print out the logo, the method name. We have to add parentheses, whether we are calling the method with or without In other languages, this is a bit different. For example, in Visual Basic, the structure is a bit different. We don't need those. And we have to add a semicolon because this is a statement, just any other statement in the languages. And of course, it will produce these two lines in the bottom. So whenever we want to call this method, we just put the line just like that. So actually what we have here is main, which is a method in itself, and it's calling another method, print logo, and of course methods can call other methods, which is usually the case because that's, if we consider the fact that in C# everything is class and all the code is put in methods, then all the time methods are calling methods. And of course a method can also call itself, and we'll discuss that more when we talk about recursion. But for now, we're not going to be making, I guess, methods that call themselves. They just call other methods. Let's see it on a live demo. Is it open? Oh, it is open. So here's our code. Let's break it before we call the method. Really? Are you serious? Optional parameters.
Error in the other.
It's in the other project. Oh, but this project is not here. Okay, let's open it again. Yes. Okay. Okay. So we had a leftover file here. So we don't need a watch window. Let's zoom in. So this is the flow of our program. This is our method declared. And now at this point of our long program, we want to print the logo. So we will call the method. Once we call the method, we can, by the way, step into methods when we click F11. That's the default key for stepping into methods when they're called. F10 will just go over them to the next line. But if you want to step into, that's usually F11. Now we are in the method. It will execute the two write line statements. Once it's finished, we're back to where we started. And we continue the program. We have an output, just as we expect. And that's it. Quite clear, right? I hope. Anything not, you know what to do. That's all nice and cool. Sometimes methods are really meant to do one thing exactly without any intervention, but many times methods are there to do something very more specific with some data to make them more flexible, and then we add parameters. Personally, I don't like the word parameters. I like the word arguments better because it's the more proper word to use in this case of method parameters. We can pass to it values of any type. We can manipulate them. We can do something with them without manipulating. So we'll see about that. And usually they will change the method's behavior according to what we send to it. although many times it won't really change the behavior, it will only change certain parts of it. Otherwise, the method is too different. So here we have a method that should print a string whether our number is positive, negative, or 0. Again. So, so this method again is a static method. It doesn't return a value, so it's void. We have its name, print sign, and we have one argument which we are sending, which is of type int and a number. Once we are in this method, this is just like any other variable. So we can access it, we can read it, and we can do things with it. We could change its value. We could do other things with it, but for now, what we are doing is checking its value, and whether it's bigger than 0, we type out positive in a new line, otherwise negative, and if it's neither, then we are 0. And like we mentioned, arguments for a method can be of any type. They could be simple variables like this, they could be arrays, they could be classes, they could be of types of any type of interface if your class is implementing it. So you can send to it pretty much anything, and it would just has to know what to expect in its. Now we have a method with 2 variables, 2 arguments. Both of them are of type float. We separate them with commas. And what it does, it's checking which number is greater. We have another variable defined here, which is called max. It's another float. We're setting it to number 1, and in case number 2 is greater, we are setting it again to number 2. And then we're typing we're printing out its value. And note that this variable here, called max, has a lifespan exactly between those 2 braces. Once our method is done and it's finished running, this variable is no longer accessible. So it's just collected out. It's actually it's declared in a part of the program called the stack, and because all the variables within a specific method are defined in a memory part called stack, and once the method returns or finishes, this stack is collected automatically, and this variable will not be available anymore.
The other one also?
Yeah, the other ones also. They are like, since those are value types, they will be defined in the stack, and they should also be removed. If those were reference variables,
we can use them in our main program. We can use the same names in our main program.
You can use the same names, yeah. They are not related to each other. Once a method starts running, it puts another memory block of its own, and those arguments can be on the same name as the caller, and they're not affected. That's part of the principle of recursion, by the way, because it calls itself, and usually with the same variable names. And this is how we call, although this syntax is invalid, what we have to do. No, sorry, this is not a call. This is the signature of the same method, and we have here float only on one of the variables. Actually, if we were to declare 2 variables in line like this, max, we could declare more than one variable, and we could separate them by a comma. But in the declaration of the method, we have to put the type of the variable next to each one of them. All right. So calling a method, by the way, another common name would be a function. In some languages, there is a distinction between what we call function and what we call a subroutine. In C#, this doesn't exist. There is only one type of method calls, and sometimes called a method or a function. So those are overlapping terms in C#. But for example, if we talk Visual Basic, we have sub and we have a function, and those are two a little bit different from each other in their structure. So calling the method which receives arguments is by supplying values to these arguments. So if we have a call to the first method which has a print sign, that means that it receives one argument. We could either send it an explicit literal number, we could send it a value by variable, or we could send it an expression like this. And for the other method which receives two arguments, we could send again values, or we could send expressions, or we could send expressions based on variables, just like that. Of course, our expressions and our types, whatever we send to the method, has to comply with the method of what our method requires. So if it's an int, it has to be an int. Of course, if it's a float, you can also send an integer, because it could get boxed into a float, and that's still valid. Nothing new in this one. So let's see the parameter methods. So now our main is a little more complex. By the way, of course, these are also method calls. Write and writeLine and parse that we've been using are, of course, methods. And since we have here a name of a type like console or int, that means that those are actually static methods as well as the other methods, which are also declared as static in our case. And once we type the code, we have the IntelliType that will help us see the structure of our method. So when I type write, I can see that I have 18 different variants of write, and when I go down and up with the arrows, I can go through them and I can see that it can receive all kinds of values. But these are actually overloaded declarations of the method, and all of them are returning void. The same goes for our own methods. If we go to print sign, which is declared in this file, I will get the method. This is called the method signature. That means that it shows me the name, it shows me that it's a void, that means not returning anything, and that it receives one integer as an argument. It has to. If we don't supply what it expects, we'll get an error. It's already showing it here, but if I try to build, I'll get, of course, build errors. So breaking again, we are reading from the console. Note that the structure here is that we have a method call that returns a value. Yeah, if we look for a minute at writeLine, we'll see that readLine, we'll see that that's a method that doesn't receive any arguments, and it has a return value of string. We'll see return values very shortly, but we are actually taking this return value here, and we are already taking it as an argument for the next method, which is the parse, which accepts in this case a string. Just to make sure that this structure is clear. So we are reading n, and we're reading m, now we're calling the print sign method. And if I step into it, we'll see that now we have a value in the number, and we can just check what's this value and go according to the right one, printing out and finishing. We're not going into any of the other blocks, and we're done here. We're going to the next line, calling it again, this time with the other variable. So now this argument will be minus 60. We're going into this block, printing out. You remember this structure of formatted strings with a 0 here, which replaces it. We're done with that. And now we're calling the third method, which receives 2 arguments. So here they are now. Note that they are floats. So they are converted implicitly into floating. And that's what we're doing. We're printing it out as a float, by the way. We're done with that, and we're done with the last statement of our program. And we exit. That's the printout. And that's it. Questions so far? It's the same as any function in other languages too, yeah, as in C++ or in Pascal or in Java or in JavaScript, even though JavaScript is a bit more loose in terms of types, but the idea is the same, yes. That's a very fundamental building block of any programming, any functional programming language, procedural programming language. So yeah, this is the code we just saw, so we won't see it again. Here's another example. We have a method that gets an integer, which has to be a month, and we have here an array of 12 strings. They are ordered by the month orders, and we're taking the integer and putting out the value out of the array. So actually we're converting the integer into a string. We're not really converting, we're just printing it out to the screen. And this one takes 2 integers, which are 2 months, and checks how many months between the 2 months. So we have 2-month numbers. We're checking the period between them by subtracting. If we are getting a number which is negative, that means that they were opposite months. We're adding to our result 12, because we have to get it to the following year. Yeah, the comment here means that the months here should be numbers between 1 and 12, just like regular months, not 0 and 11. So we're going to add 12 to our result. That's because our other method takes the number and reduces it from 1 to 12 to 0 to 11. You see that? So we're actually taking the value and making it, normalizing it into an array between 0 and 11 value to have the index correct. Once we have that, we know the period, and we're printing out the name of the month by calling same month, which is the previous method that just gets them out of the array. We're printing them out here from this to that. And that's it. Let's see it. Okay. Of course, this program assumes that our input is valid, so that's really a number and it's between 1 and 12. Otherwise, we don't have any error handling here yet. So we're reading from the console as usual. Okay. And we're reading again. And now we're calling the method say period. And we're providing the two numbers that we've given. Let's step into it. Here we are. So we have our start month and end month as arguments. We have our local variable period, which will take both and subtract them. And since this number becomes negative, we will add 12 to get to the positive result. In that case, minus 6 will become 6. Now, first of all, we're printing there are 6 months from. Now we're calling the method same month. So we're going to convert this number from number to string. So let's see, step into the same month method. Here we are. We're getting here another argument of 8. This is our array. So we'll take the number 7, which is the 7th month, which meant that 8 is translating to August, and printing it out and returning. Now we're back here to where we called. Now printing another. Now calling it again with a different number. So here we are. Again, we're declaring the array. Not very effective, but it works. So we'll translate this to February. And print a dot. And return. And finished. So the end result is that. Actually, it was a bad example because 6 would become 6 in any way, because from August to February is just a number between February and August. I should have taken a number with a different number from this year to the next. But the principle is clear, I hope. As for this code, of course it could have been united into one statement. So we could have had, instead of write line and same month, we could have put everything in one write line method like this. From, I'll just put another argument here. And I can put the function call here. What's missing? Oh, I couldn't do that. Sorry. Because this method doesn't return a value. Yeah. If this method had returned a value of string, I could have put it here, but actually it expects a string here, and this method is a void. So this method is a functional method. It does something and finishes, and that's it. It doesn't return anything functional to me. It's a subroutine. It's true. Well, another example of building a triangle by a specific number. So we get the height of the triangle changed by a specific number. So here it is. We have a method called print line, and it gets a start and an end. So we get the length of the line. So what we have here is a for loop that calls the method every time the loop goes in, and inside the method we have a for loop as well. It's like a nested loop, but the other loop is inside the method call. So once we have a number n, we'll go from 1 to, let's say, 5, and on every line we're counting 1 and then 2 and then 3 and then 4, and every time we'll print a line with console which goes from the first number to the number that we've reached inside the loop. Not very sophisticated, but it works. I don't know if we're going to be really going through each line here. That might be a bit too much, but we'll see it. So we'll be breaking here, not on every line. Let's put my favorite number. And here we go. Just to take a look at what's going on, we're going to start from 1 until we reach the number that we've given, and on every iteration of the loop we're going to print a line. So print a line means go into the method, and again we're going to start from 1. Now we're on 1 to 1. So we're going to do that only once, and we're going to go down. Once we're done, we're going to down to the next line and return. And now we're back in the first loop, and we're going to go to the next value. So that one is 2. So we're going to call it again, and this time it's going to go from 1 to 2. So if we step in, we'll see that the loop now will go from 1 to 2. That means it will go twice. 1 and 2, finish the loop, go down, and go back to where we started. And again, so we are increasing the length of the line every time we're printing more and more characters until we reach the line that we've chosen. And then we're doing it again, but we're just starting from the last value and going down until we reach 1. So we are decrementing. And the result, as expected, would be a triangle of counting from 1 to 5 and then going back down. Clear? Optional parameters are I'm not sure they started with .NET version 4. I think they were there before, but I'm not 100% sure about that. In any case, as we've seen, we can declare parameters to our method, and we have to call our method with the right parameters provided. But we can also set them default values, and that means we can in that case not provide them. In this case, we have a method that prints all the numbers between the two given arguments, start and end. It just loops through all the numbers between them, given that they are integers. Just that we have a set value to them, and that means that if this variable is not provided, if this argument is not sent to the method, it will automatically have the default value of 100. And if this argument is not sent to the method, it will automatically have the value of 0. So in that case, we can see that all these calls should be valid. Once, this is the normal call where we're providing two variables as expected. The second one is that we're providing only the first variable. So the second one will be 100 by default. This one doesn't provide any variables, so we are getting the two default ones without doing anything. And this one provides them with a named reference. So we can actually, as you can see, they are swapped in their order. The start is the second one. But that means that we're providing this number as the value of the start variable and this value as the value of the end variable. So we can provide whichever of them we want in any order that we want. And if we miss one of them, they'll still be valid. The call will still be valid, and they will have their values. This comes in quite handy in many cases. So you can immediately create a function that receives variables and doesn't receive variables at the same time. Or if you have some kind of defaults that you want or don't want people to provide, or if you think that many times they will not provide a value, you can provide it yourself as default, and they can override it if they want. That's a very useful feature.
I have a question. Is it necessary to have an optional parameters if we want to declare our methods, the last option, which is with the names?
No. No, I think.
Use it as standard?
I think it can be used as standard too. I think so, but we'll see. We'll check it in a moment. Let's check it right now. I think it should be working either way, because this syntax is working. Yeah. Yeah, but then I'll have to remove all the other calls. Let's first run the regular scenario. So here's the regular call. So when we step in, we have the values as they are provided. And okay, we won't run into the whole method. We'll just step out. By the way, if you are in a method and you want to step out in the debugger, you can do Shift F11 and you'll be stepping out of the method. That means it will let it run and just put you back to the point where it was called. Also handy. So now the second call, we're calling it with one of the variables. So we're here. The start variable is set, but the end variable was not set, so it gets the default value. And we're going in and out. Now we're not providing any variables. Stepping in, we have both defaults. Blah, stepping out, and referencing them by name. You can see that start gets what we put in start, and end is getting what we put in end, and so on and so forth. Let's remove the defaults for 1 second. We'll see that all the default calls are invalid now. These two. But this call is still valid. And if we call it, we'll see that they are still set by their references without. This is not about defaults, this is about calling them by reference, by name. But default values are cool and useful, and they can save a lot of code writing. And by the way, there is a semicolon here. That's a mistake. I just noticed because variables are separated by comma. Yeah, not all the methods, but many of them will be returning values. That means they'll be doing something and they'll be returning something to the caller. Yeah, we know this example. We have the readLine method. It returns a value of type string. So we can take this value and assign it to a variable like we're used to. Or we can take this value and put it in another call, for example in parse, like we're used to. Or here, for example, we have a method called getPrice, and we're just using its return value as part of the expression. Or here, like I just noticed, there is a readLine method that returns a string and just take this value and puts it into the int parse. And we've seen that many times. In order to return a value, all you have to do is use the keyword return. So we have a method here, again static, and now we are not using void keyword, we're using the integer type. That means this method has to return a value of type int. By the way, if your method is throwing an exception intentionally or unintentionally, then of course it's not returning a value. So that's one of the options in your method. That means that if you are validating something or checking some value or doing something, you can also throw an exception in the method and you won't have a compilation error. In any other block of code which is in your method, you have to return the expected value. I'll show you a little more of that in the debugger. So we have the method here that gets two integers and returns a type of integer. And we can see that it returns the value of the expression, first num times second num. They can of course return any type, just as they can receive any type as argument. They can return all the primitive types that we know. It can return any class. It can return anything which is relevant to a specific interface or class. So that's it. And as I mentioned, the combination of what the method is looking like, which we saw also in the debugger when I was typing, is usually referred to as the method signature. Just the name of it, the parameters it expects, and what it returns is usually the signature. And the return keyword, as I mentioned, is what returns. The return immediately steps out of the function. That means that if you have a return statement at some point, the code after the return, of course, is not executed. We'll see that too. If you have a method that returns a value, for example, an integer, we'll have to return it like this. And if you have a method that returns void, you can terminate it at any point by calling return without any value. It would still terminate it correctly. Or, of course, you can throw an exception. That's also one way to terminate your method in an unelegant way, but sometimes necessary. So let's look a little bit into returning values. All right, so here's our method. It gets a double as an argument and returns a double, and it calculates, it converts the degrees from Fahrenheit to Celsius. Yeah, that's important. That's why it's important to read the method's name. So there's a small calculation here, which I'm not sure if it's right or wrong. Haven't really explored the Wikipedia article about that, and I usually use Celsius. but for the sake of example, it's good enough. What we have here is another variable called Celsius, which is being populated and then returned. Of course, we don't need this variable. We can just return the expression here. Declaring a variable is just a little bit of a waste in this case. And again, what we have in the program itself, reading a double and then calling the method. And as you can see, the method is using the variable that we declared the line before, and it takes the result and it puts it back into the same variable. So it will take the temperature that we are reading from the console, it will run the function on it, it will return a value, and it will replace the value with the returned value of the method. That's totally legal. And then it will print out the Celsius degrees, and it will also say if you are sick or not. Very cool. By the way, I've been told by some Bulgarian that the normal body temperature of over 36 is considered sick. And I totally disagree with that.
But it's said by Bulgarians, so you don't have that option.
Yes. Yes, I've always known that it's 37. And then I measure my temperature and it's 37 or 37.2, and then, oh, but you're sick. But I'm not sick. Oh, but you're sick. Maybe they didn't mean the temperature. I don't know. But
Was you involved in that one? Again?
Interesting question.
This example has a bit of error. If your body temperature is below zero, you're also ill.
Yes, that's also true.
Almost too bad.
You're terminally ill.
Yeah.
In the end, if Bulgarians say that, then it's true.
Then it's true. Yeah, it's true. We need another boundary here. But let's just say if you can read this, then you are not yet dead. So let's just run it. And unfortunately, it's taking it in Fahrenheit degrees. I think, yeah, 100 is high enough, I think. Is it? So we have here our temperature as we've put it in the console. It's parsed as double, and we're calling the method, so we'll step into it. Here we are. So we build the expression. We get very sick.
More 30.
And we're returning value. So we are returning from the method, and we're putting the value back. So right now our value is 100, but after we have returned the value from the call, by the way, of course, one more thing to point out. Let's open for a second the watches window, which I find the most useful of all debug windows. In the watches, when you are running an application, you can of course take a whole expression with a function call and put it in the watch. You'll get the result of the method call. So that could be quite useful as well.
I have a question. I've used this this technique, but I noticed that sometimes when we press F10 to step to the next line, it doesn't get automatically revalidated.
No, it doesn't. Once you're stepping, and if it's a method call, you'll have to refresh your expression.
Is there another way of doing this, and so it can be auto-refreshed?
I guess it would be kind of a hack. I don't know. I'll show you. So here we are in this line right now. We're debugging, and this is an expression that I put in the watch, which is actually calling my method and showing the returned value. But if I go to the next line, by the way, went to the next line and we replaced the value of the temperature now, and you can see that this now became gray in the watch window. That means that this value is probably might have changed, since something in the program has changed, the conditions or the runtime, something might have changed. So in this case, there's a small refresh here. When I click it, it will rerun the function and will get me a better value. This happens in many, not only in function calls, but in many complex types that you're putting here. Whenever you run to the next line, it will invalidate the watch parts, which are not sure that they are presenting the right data. So you might have to refresh.
If we step off and then you get refresh.
If you go to the next line, it would usually invalidate it. So here we are. We have the converted temperature now. Oh, look at that. Actually, that's interesting. It got invalidated because the original temperature was 100, and now when I rerun it, the original the temperature has been changed to 37, and when I run the function again with the current temperature, I get a different result here. So that's a result of the refresh of this watch window. So that actually does make sense that we would have to refresh it to see a new value in this case. So we're printing out this, we're checking that, and we're printing out this, and that's cool and done. I want to go back up to the function and notice that if I write any code below the return statement, I'll get it in gray, and I'll get a comment here that this code section cannot be reached because we are already below the last return part of the method. So just so that you know, you can add code after the return, but it will never be executed. Also, if I put an if here, for example, I want to check if Celsius is greater than 220. And then this return becomes a part of the if block. And I get an error here that will not build, because not all the code paths in this function are returning a value. It is required for this method to always return double. However, for example, if I put an else here and I throw an exception, no matter what, then my code is okay. I don't always return a value. In some cases I throw an exception, but it still means that every part of this function knows what to do. I can also return a different value in this case. And of course, below this if-else statement, whatever I write is already beyond the reach, and the compiler knows that. And by the way, if I return the two, in both cases I do the same thing, I'll also get a comment that says that both code blocks are actually equal, so there is no need for the if and else in this case. So it's smart, and always know that you have to, if you're returning a value, make sure that all your paths are returning. Another part of good practicing when you're building a function, it doesn't always work like that. In C++, that could be a much greater issue, because methods can more easily create memory leaks and all that kind of crap. In C# we have to worry about that less. But another part of good practicing when you're writing a method, and it's a recommendation, of course, in the real world it will not always work like that. But when you can, I recommend always have one return statement if you can. That means do everything here, manipulate what you want, change the values, or if you have some kind of variable here, you can play with it, make sure that it's always containing the right value, and then put your return statement in one place, so that the flow of the function is always clear. It's doing whatever, it's changing, it's manipulating, and then in the end, whatever it has produced, it returns.
Only one exit door.
Yes. Not always a good advice, because many times you do have to put, well, you don't have to, but it's much easier and makes it more clear to put more than one return points. Questions? Yeah, that's the code we just saw. So, great. Yeah, here's another example. This method gets an array of integers and returns a boolean. So two completely different types. And it goes into each of the numbers in the sequence. We're doing it for each, not with a for loop. Just make it easier to program. And once we find the number which is smaller or equal to 0, we are returning. So here's an example of something that just returns somewhere in the middle of the loop. I would not probably do it this way. Yeah, you could just break here. You could define some Boolean variable here. You could set it here and break out of the loop, and then just check what this variable contains. Yeah, if you have nested loops, it's much harder, but still, in some cases, it's prettier and more elegant to just do your loops, finish them or not finish them, and just return what you've computed. No, you break out of the loops. You can break out of the loops. In any case, you can have.
Assign to the loops and value.
Yeah, you assign some value and you break out, and this. Yeah, of course, it's not. Again, this is not always the case. In some cases, it's much better to just break out. It's not pretty. Personally, I don't like methods that just break out in the middle, or in the middle of a loop. It's better when the loop, even if the loop breaks, and then you just leave the method in a known point. It's
in this case you can use while.
Yeah, you could use while. You could use for. For example, you could use for, and one of the conditions of the for is that my variable is not yet false. For example, I could have a variable here, and once this variable changes, the for loop will be automatically terminated. And then I'll just.
I found that this is really useful to use different conditions for your for loops and for while loops.
It is.
Use a lot of conditions.
Yes, it's true. In this case of the for each, of course, it doesn't work, because for each uses an enumerator to just scan them all. So we can either just return or just break it. But this still would work. So, for the sake of example, it's cool. This is my personal preference, so don't take it personally. So here it is, I hope. Oh, we're going to read all these lines. So first we read how many elements, and then we read them all one by one. So that means I'm going to have to take a relatively low number, and we populate our array in a loop, every time reading a new number from the console, and then we're calling our positive method. So we don't need all the first part. We'll just take 5 numbers. So here's our array filled with data and our boolean.
This is really bad names. I mean,
Why?
it doesn't start with it doesn't have any word in it.
That's true, but that depends on the functionality of the method.
Also, this spaces between the equal and the names.
Here, these spaces. No, these spaces are perfectly fine. Actually, it makes it quite readable like this. And as for the name, of course the name can be anything, just like a variable. In most cases, the standard is to name methods starting with a capital letter. And it also depends what this method is doing. If this method is returning a value, a Boolean value, it's usually is something or are something. So you can say is positive, and it will return true or false according to that. Or in this case, we have an array, so it's are positive. Or convert, whatever it does, convert to. Yeah, according to me, it is. But of course, you're the developer, and you choose the names. Names are not to be lightly picked. I mean, you have to think about what you're naming your variables. You have to think about what you're naming your methods, and it's not always so trivial. But in this case, I think it's okay. It just returns true whether they are all positive. And stepping in, here is our sequence, which is the same array. We're going in. We can follow the number. So now we're on this first value, checking, going to the next, checking, going to the next, and now we are stepping away. We're out of the method, and we're populating the variable and printing the right message, and we're done. Questions about this example? Okay, here's another example. Here we have 2 methods, validate minutes and validate hours. They are two different names. They both get integer and return a Boolean. So in the case that we have minutes, we want to make sure that the minutes are correctly put between 0 and 59. So again, we're populating a variable and returning the result, and this variable gets the Boolean expression that that the value is greater or equal to 0 or smaller or equal to 59. Again, we could have just returned this value, this expression. We don't need to populate and then return. But for the sake of example and for clarity, I think it's okay. Hours, we probably do the same. So the hours could be from 0, let's say, to 24 or to 12, depends on what's the definition. And here's our main class. We are reading from the console first hours and then minutes, populating two variables. Now we're calling validate hours and validate minutes. We take both values from both return values into one expression. We put an end into them, and we put the result into another Boolean. And then we check the value of this Boolean. And we print a console line according to the result. Yeah, you see how it's intertwined? That's it. So here's the two methods. We have 0 to 59 in the minutes and 0 to 24 in the hours. And here's the main block. Reading the hours, reading the minutes. And now we are calling both methods in one expression line, taking both values, putting an end, putting them into a Boolean variable, and then checking what we got in the end. Yeah. Yay. Okay. So before this line can be executed, both methods have to be called. And so the first one will be validating the hours. So if we step in from this line, the first thing we get into is validate hours. So we get the 5, we get the result, which is in this case true. We return, and we're still here. So if we step in again, we'll go to the validate minutes. And here we are. Minutes are here. The result is false, of course, returning, and only now we will have a value to put in the isValidTime, and once we execute it, we'll see that it's correctly placed as false, and we can go to the right block and put it here. Of course, also here we don't really need this variable. We could just put both of these expressions as they are into the if statement, and that will also be valid. Of course, in some cases it's good to have a variable because sometimes it has more than one use, like here. Depends on the complexity of your program and your needs. But if you really don't need it outside this if check, then you can just take the whole expression and put it in the if, and that will also be okay. Cool? Still recording, right? Now I have a phobia of stopping the recording. Yeah, not the best politically correct picture, but that's okay. Overloading methods is a powerful part again of object-oriented programming. By the way, what's the time? How much do we have? We could have a quick coffee break before we get to the exercises. So, overloading methods is an important part of every object-oriented language, and it also gives a big flexibility for the users of your functions. We've seen overloaded methods, for example, in the console write line, because we saw that console write line has many options. It can receive string, it can receive int, it can receive float, and all kinds. So your method can have not just one type of variables, that can have different signatures, getting different variables with different names, with different types, and with different numbers of variables. So in this case, we can see three different methods. They're all called print. They're all voids. They're all static in this case. The first one gets an argument of type string. The second one gets an argument of type int. And the third one gets two arguments, one text string and one integer. And this is valid. This is okay for all of them to be in one block. They're not contradicting each other, even though they all have exactly the same name. Just like when this one calls writeLine, it can send the string. And when this one calls writeLine, it sends the int. And when this calls writeLine, it sends, well, a string and a converted integer. So also writeLine is an overloaded method in this case, and it can be sent each one of these variables. So in your program, you can call print with each one of those signatures, and it will still be okay. So overloading is the return value. I would say it might be a problem.
I think no, because I couldn't get it to work.
Yeah, it might be a problem. Another type of powerful feature is the variable number of parameters. There's a keyword called params, which afterwards you can specify an array of variables. And that means you can call this method with any number of variables of type int. So in this case, we can see that calcsum, this method, can be called with 2 integers, with 4 integers, with no integers, and once we are defining them as params, whatever you specify here as parameters will be transferred to the method as an array of the parameters. So in this case, we'll get an array with two variables in it, 2 and 5, and we can just go through them and do whatever we need.
So params always be used with an enumeratable type.
Yeah, with an array usually.
Array.
And actually,
do other enumerators work like this?
I think it requires an array in this case. Also, you can not of course, but you can create other arguments except the params, just that the params needs to be the last argument. And so it could have other arguments before it, but then it could have any number of arguments once you reach the params area. You can pass it as an array too, yeah. You don't have to pass them like this. You can also pass an array as an array. That will
but more arrays than one?
No, unless it's an array of arrays.
I don't see any. I don't see any difference between using passing just an array or passing params in, because only syntax.
Yeah, it's a matter of syntax. Once you have params, your user of your method can send whatever he wants, or she. So that's quite powerful as well.
This kind of list array, it's accepting some kind of list array.
An array, not an array list. Not a list, as far as I know.
Because you can throw as many parameters.
Yeah, you can throw. Of course, your function can receive one parameter of type list or of type array. That will also be valid. But in the case you you specify it with params like this, then all these calls will be valid. Whatever the user sends will be okay. It's easier sometimes for the user. And if we look here, let's quickly write one. So this method will receive a string str and then params numbers. Will do nothing for now. And when I use this method, I'll see that I can see that it's also specified here in the list that we have a params argument here. So I can send a string, and then I can start providing 0 or more integers, and it will be still valid no matter how many. And also, if we look at console write line, for example, we'll see that we have the regular values, and okay, here we have params. So we can send, if we are writing our string write line like this, and now we can specify as many strings as we want. Yeah, that's quite a different one, but we can see that one of the options is using params. Because if I send here a number, we can actually send. This is a bit more powerful because because we have a string at first, which is our printed string. Once it has replacement arguments like this, it will resort to the params, and the params are of type object. So they could be of any type and any number of them. It will know how to handle those. So I can put here a string, and I can put here a number, and I can put here a float, and I can put any kind of floating number, and it would still be valid. So I can put here as many arguments as I want, and of any type I want.
So what if we don't have a string?
In the first place, then we have a problem. Because the overload of this method with the params requires the first argument to be a string. Put an empty string. It will also work. Or you can use string.empty. It will also work.
Does the param, can we set default values to the param?
To the params.
Yeah, that's great.
Interesting. No. No, it won't work. It has to be some kind of constant, and this type is probably too complex for it. Right. So, as for best practices, some of them were mentioned. A method is some code block that needs to do something well defined. So you need to choose what your method is doing, you need to put the right code in it, you need to name it correctly, you need to make sure that it's clear, and that's the power of this building blocks. So you should give it some kind of well-defined name, usually started with a capital letter. Don't call it F or G or process or something which is completely useless. Avoid methods that are longer than one screen. Again, not always working, not always in practice. It won't always be easy task, but it's good when you have compact methods that are very well focused on what they're supposed to do, and if they need to do something more complex, they call other methods that do the other smaller task for them. So it's a good practice to break down your code as much as possible to the most understandable blocks. It's a good practice when your code is well defined and you have a method that you know exactly what it's supposed to do. Once it starts being a little bit too long and doing this and in one case and that in the other case, it might be a little bit confusing and not well. So that's why splitting them into screen size and to shorter and more methods with shorter methods and more of them is better than one long method that's complex. Yeah, we've seen all that. Parameters, we've seen the power of overloading and optional parameters and the return values and all that. Anything?
Can we return more than one?
Good question. Basically, no. But in practice, yes. Yeah. If you remember, we used a method called try parse. Did we use it? I think we used it. Or we didn't use it. Let's take a string. So we have a string here with a number, and we can call int parse. And here we have a static method of integer that takes a string and returns an int by parsing the string. In this case, I'll put the num, and I'll put here an int parsed. The problem is that int parse can crash if I don't send it the right type of value. So if this string contains something which is not a string, not a number, it will crash. So in this case, there's another method called try parse. Instead of throwing an exception, try parse has a return value of Boolean. It takes a string and it has something called an output parameter. So it will populate a parameter for me and return a value at the same time. So in this case, I can take my parsed value as a different variable, and I will provide my string and so in this case what I have is a method that does two things. It populates a variable for me, and it's by using an output variable, and returns a value at the same time. So it actually does return in practice it returns two things. So you can also declare a method not like that. Must be some value, okay? No.
You can calculator.
Yeah, but that's a problem. It's like a return value. You have to assign some value to it and during the method call. And in this case, this method returns nothing, but it does something with my variables. It will have to populate them for me. And by the way, as you could see here, this was a valid call. I provided the method with an uninitialized variable, so that was okay. However, if I call if I call another function like let's call it int parse with my string, but suppose my string is not initialized, I'll get an error that I'm getting a function call with an uninitialized variable and it will not know what to do with it. It needs to have a value in this case. But in the other value of the out variable, I'm sending an uninitialized variable and my function must populate it, just like it did here.
So parse is replaced with the out.
Yes. It's as if it has more than one return value. This is something to...
Can we use more than one out?
Yes, you can declare as many out variables as you want.
Also reference.
Or reference, yes.
Is something like pointer to the object?
Yeah, pretty much. It takes a reference and it has to...
What's the difference between out and ref?
Sometimes it's a more semantic.
Ah.
Ref means taking your variable and either changing it or not. Out means this. It's like a return value. This method has to do it for you.
Something like params.
Something like.
In the logic sense.
I think that's the difference that ref means that your method is depending on this parameter you're sending, this argument. When out is depending just on the other.
Well, ref means take this variable, it can change it for me or it cannot. It just takes a reference to it and for some reason, of course,
you. It's not taking this argument.
It's
not using it, this argument.
It could in a way. I'm not sure if I could.
If you are assigning, for example, parsed something, he's going to use it in your method.
Oh, that's not a string.
Well, you must return the out methods for sure. That means for sure to overwrite the new.
Let's take some string. No, sorry. No, it's treating it as unassigned. So it assumes that it's not assigned a value until you put it into it.
So that means that out just returns, it can't use the argument.
Yes. Unless you put it in a... No, still doesn't. Even if you put the default value.
It means out.
Yeah. Good question, though. Yeah, although you can also use the keyword ref. That will really take your variable as reference and can change it, which is more useful when you're using values like int, which is usually in C# transferred by value and not by reference. But you can use the keyword ref on your argument, and it will be passed as ref, and I can change its value inside the method. But out is like a return value. It's expected to be returned from the method. It's expected to be populated and returned correctly.
something about static and public.
We'll talk about classes and we'll explore.
Because I had problems recently with this. Because the other thing I noticed that you can declare some arguments and some parameters with static, and they depend exactly. It's depending on how you are declaring.
Yes,
this
that's true.
argument.
But
And I couldn't understand how I can use that.
we'll cover that. Yeah, I will.
I have a question. Is string passed by default as by reference or by value?
By reference, I think.
Telerik.
What if the alpha variable already has a value? Is it changed? No.
Yeah, it will be. Yeah, all this.
It will be changed for sure.
It will have.
For sure, because it has to return it.
There
and
is no option.
Yeah, it's being treated as if it's uninitialized in the function call, and it has to be
initialized again.
initialized and returned. All this thing with static public, it's not related to static public. Public is something different, static is something different, but we'll explore all these much deeper when we get into classes soon.
I have another question. When we are returning, for example, array, and we are also taking as arguments an array,
Mm-hmm.
we have already one array, which is the returning.
Yep.
If we sign it as clone or copy it or give it the equal sign,
Mm-hmm.
it's going to return the same array as the
Depends how you, if you do a clone or a copy, which are not deeply copying, then you'll get, I think we saw that, you'll get a reference to the same one, to the same objects in the array, so that whatever you change in the return will affect, yeah, it will.
It's not going to copy my array.
Not to
Thereby
a not to a
change
separate
it.
one, but you have to make sure that you are making a deep copy of your array to another one if you want them to be completely separate, because arrays are referencing memory blocks.
Deep copy. What do you mean?
We saw that when we were talking about multidimensional arrays, that you can copy an array values from one to another, but you have to. Yeah, but you have to make a deep copy to make sure that your values are really cloned to different variables one by one. And if they're complex more, if there are classes inside your array, you have to make sure that you copy your values into another instance of the class.
So this means you have two complete arrays, and one is inside a method. When you change one inside the method, it changes the one outside.
Yeah, this would work like that for most. That should work like that in most reference variables in C#. There are reference variable types and value variable types, and that's how they differ.
And you shouldn't.
But string doesn't work like that. String is array, but it doesn't work like that.
I don't remember, but I think it's a type that works by value, but I'm not sure. I have to check it out.
It's usually array of chars.
Yes.
Because
But it's-
yesterday I have a homework in C++ and I was quite amazed that it was passed by value, not by reference.
A string.
Yes, string, I was really surprised.
Mm.
And I had to, if I wanted to work with the string, I had to use ampersand, so pointer to the string, so I could be sure that when I change the string in my method, it will be changed in the main method as well.
Is it a C string or is it a char pointer?
No, string. I include string.
That's okay, because most of the classic C++ strings are usually character pointers,
No,
and they
I
are.
was just a regular string.
Okay, that depends on the implementation of string, because it's not string is not the basic.
Yeah, I was including just string. I noted that including or not including in the start of the program the library string doesn't change anything. It's always possible, and it was strange for me.
Strange for me too. Okay, more relevant.
Just last thing, can we override by returning type?
No, I think the return type has to be the same. Yeah.
So we have different methods.
I tried this 5 minutes ago, and the compiler said that it could not know which of the two methods to use. Because
But your returning types were what?
well, the one was void, another was sinter, and I tried with double and tint, and it didn't know which one to use.
Differentiates between them by the arguments. And
Yeah, only by the arguments.
Not by the. Well, if the arguments are different and the return type is different.
That
Yeah.
probably could work.
That could work.
As long as you're not ambiguous on what you're assigning it to. If it's an in or a long, then you could have ambiguity. Right. I'm not sure we have time for a coffee, but I mean in terms of the cafeteria. But if you want to try our luck, now is the time.